Once again, it's time to talk about a gigantic milestone made in the medical sciences field that is coming from China. Chinese researchers have reported early and initial results from an experimental surgical procedure that modifies the brain's waste clearance channels and thus seems to appear to cure Alzheimer's. The procedure is called cervical shunting, and this operation was performed on multiple patients, especially an older woman who will be primarily discussed here. After 5 weeks, her cognitive function improved, her dementia rating fell, and her score on the geriatric depression scale also dropped. So what did these surgeons do? First, let's look at the brain to understand what happened. Now, there's the glymphatic system. These are the drainage channels that are in our brain, and the glymphatic system is the waste transport channel. Studies have shown that blockages in the glymphatic system, where these lymphatic fluids drain, leads to an increase in the accumulation and deposits of certain kinds of proteins, such as tau proteins, which then subsequently leads to Alzheimer's and other neurodegenerative diseases. So, acting on this correlation logic, a team of surgeons who specialize in surgery, the more delicate microsurgery, and the even more dexterous super microsurgery, extremely fine, all of these kinds of surgeons came together to develop a procedure that will relieve blockages in the glymphatic system in an Alzheimer's patient's brain. This surgery allows for the high-pressure lymphatic vessels to flow into the low-pressure veins after getting unclogged, essentially. So it loosens up all the walls so that the channels have more flow and then drains out the lymphatic fluids. The ultimate goal for this procedure in this specific experimental surgical procedure is to remove proteins like beta amyloid and tau proteins whose buildup leads to Alzheimer's in the brain. This team operated on 6 individuals who were all a part of this trial. All 6 of them experienced mild delirium after the surgery because of the amount of anesthesia required, but all of them got over it, and then subsequently they began to show cognitive improvements. The older volunteer, the elderly woman that we talked about earlier, was a 70-year-old Alzheimer's patient. Her daughter brought her to the doctors in December of last year, saying that she had been experiencing memory loss that was worsening, anxiety and depression since going back to 2018. In fact, it had gotten to a point where she was not even forming new memories, and she kept forgetting events that occurred merely a few hours prior that she was involved in. So this was quite concerning. When the initial team scanned her brain, they identified her as a potential candidate for the surgery that was being conducted by a different team. And she also met the full requirements of being a fully diagnosed Alzheimer's patient. So she transferred to the clinical trial and she underwent this cervical shunting surgery in January of this year. Then her clinical assessments began. Now, 5 weeks after the surgery was completed, her dementia, Alzheimer's, anxiety, and depression ratings all fell. And in the same tests, her cognitive abilities improved. Her memory improved. There was an increase in brain glucose metabolism and overall reduction in those tau proteins as well. Now, this is amazing news. All of this is pretty awesome. It's a huge milestone in our treatment towards Alzheimer's. And the surgery seems to be straightforward. You start draining all of the accumulated proteins and then Alzheimer's doesn't develop. So that's pretty awesome. Does this mean that these scientists have cured Alzheimer's by surgically altering the brain? Not really. The research is still ongoing. The first thing we need to remember is that this is very, very early results, deeply reported in 1 person and also reported in about 4 to 5 others. That is not enough data. This procedure and these results need to be replicated in large groups of people, tens of hundreds of people, before this becomes accepted as an actual treatment for Alzheimer's. Secondly, Alzheimer's damages the brain, the physical structure of the brain. Once the brain cortex is damaged, it does not produce new cells and it doesn't regenerate or heal itself, which is the typical problem with all of these neurodegenerative diseases. They are progressively degenerative because they alter the physical structure of the brain. So at the moment, specifically for Alzheimer's, it appears that this surgery helps improve brain lymph drainage and has shown improvement in some people. But there is a long way to go before this can be officially adapted and accepted as a worthwhile treatment for Alzheimer's around the world.